wait for others also. Right? Could we start? All available.
Yes, sir.
Okay. So now let us start with the previously planned. And that one is load balancer. You know what load balancer is?
Sir, it is actually used to manage and divert the traffic which is actually incoming onto the server or to a person's computer network.
So as a few days back we had discussed of what are various zones like militarized zones, uh, what are the different sort of landing zones or where actually VMs are being spun up. Let us take an example of cloud environment now. And we will be talking specifically for AWS cloud. Generally, Azure will be having the similar structure and architecture. The names will be a bit different. Okay, the nomenclature of their services is a bit different. Nomenclature of the services of cloud AWS is different. Okay. So let us take an example. What basically landing zone is, then we'll be clear of what is the actual need these particular things. Now, in AWS itself, we have VPC. Anyone had worked or hands-on experience on AWS? Done anything on AWS? Anyone? Gautam. So Gautam, you know what VPC is? Had you ever, if you have configured any of the VM or EC2 instance over there, then it is prerequisite to have these networking artifacts running so that you can place your EC2 over something. So you know what VPC is? Have you ever created a VPC on AWS Cloud?
Virtual private
Yes,
cloud?
sir. It's virtual private cloud, and like we have to create what you can say groups, user groups.
Yes.
If I'm not confusing it with Google Cloud, we first
Mhm.
have to like create an organization group. Then
Mhm.
it gives us access to various services like IAMs and whatever the resource we have to allocate to those groups. And that creates a virtual cloud. Then there are following services like particularly talking like you mentioned EC2, the virtual machines spin up. So
Mhm.
that also acts as a load balancer. And like I tried it with the application, hosted a Java server to it, Java servlet
Mhm.
to an EC2
Mhm.
instance. So it scales up and scales down according to its needs. So that
Perfect.
is what I've done with AWS.
Okay. So now the thing over here is now we will not be going into depth of cloud itself. Basically, to use cloud, we need subscription. Subscription is something what you need to pay for. They will be giving us some account. In that, in Azure itself, we'll be creating tenants. So that is something different. We will not be discussing. That is encapsulated abstract to us. We'll be talking of the things of services what we'll be using inside that subscription. So, for analogy to the on-premise infrastructure, cloud is also providing us some sort of infrastructure. And infrastructure comprises of the servers or virtual machines as well as their interconnection and the landing zone itself, which is networking. Without the underlying network infrastructure, we can't be able to spin up a landing zone which will be viable enough to serve the application or anything in a persistent manner. Means to make the applications serve the thing, we want a architecture, full end-to-end architecture. It will be comprising of basic networking needs, how various machines communicate to each other, how various machines are being communicating to internet, how they are being communicating to databases. All the communication is being taken care by the networking whatsoever we had architected onto the. Understood? Now, the first and foremost part in any cloud service provider to have a network space over where we can have permissions to work. We can have permissions to make other sort of networking infrastructure or the VM infrastructure. So in AWS cloud, they name this as VPC. That you will be given a space, a set of IP addresses allocated to you, and those for VPC itself, those will be private kind of IP addresses, and for public itself, we want to explicitly resolve the things and ask them to give me a public subnet or give me elastic IPs. So this will be up to then the cloud service providers like AWS also, how to fetch a pool of publicly available IP addresses and then place or then give it to the artifacts or instances. Here EC2 is instance, so that they can be communicating over to the internet also. You understood the previous concept of public-private IP address because that is a base to this. Underlying base of all this discussion will be the actual IP addressing scheme. May it be public, private, may it be dynamic, static, or so. You people understood that particular thing now? No? Because we had the talk about this particular thing, I believe, few days back. Japneet, understood this basic terminology?
Yes, sir. Yes, sir.
Okay. Now to start up over here is VPC is nothing but a private space given to you people where you can spin up your instances or machines or anything. So in AWS VPC, we want to create, if we want to create VPC, they'll say, give me the CIDR. Give me, AWS will ask you or the control or the any, what we can say, that portal will ask you that while creating VPC, they will be saying, give me the CIDR. What VPC you want? CIDR is nothing but the
Routing.
IP address. So CID, the what IP address space you want. It be private. Like I will be saying 10.0.0.1/16. I want this CIDR for my VPC. So what it will be doing is it will be giving me what, because for 16 itself, these will be the network and these will be the hosts. Okay. You understood the terminology of what 16 is, what subnet masks are now. So what they'll be going to do is, this is private scheme itself because 10 is private. It can be used by other VPCs because because these IP addresses, private, will not be communicating to the internet. For communication to the internet, either we need an internet gateway, like we had discussed that day. We want to translate the addresses to the public itself, then the communication will happen. So these will not be reachable from internet, the private. So because they will not be reachable exactly from the internet like 10 series, so they'll be available for other VPCs or other members over the globe. They can be used by multiple number of people. Okay, because they will be on their own chunk or packets itself. Okay, for need of for communicating to internet, then they'll need public IP address or internet gateway address also to have the actual communication. So they'll not basically uh, interfere with any other address. So in this particular CIDR, or if we'll be creating VPC, then it will ask what CIDR you want. CIDR means, if I'll be saying no, my CIDR will be for VPC will be 10.0.0.1 /16. 16 means 16 bits for network. So because of these all are 8-bit, 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 8-bit. You know IP address scheme, 32-bit scheme. So first 8 plus 8 will be 16 bits. So what it will do is it will reserve the IP addresses range from 10.0.0.1 to 10.0.255.255 for me, for this VPC. Then it will translate to that this particular range I can use inside my VPC. I can now create various subnets. I can divide this address space into various sub-address spaces. That various sub-address spaces is called subnet. You can have n number of subnets over there. For the sake of now, the thing is, first is VPC, then comes subnet. To spin up the cloud or to spin up the instance in AWS. Normally, when we spin up the EC2 instance in cloud service like AWS, we will be clicking EC2. It will do all this for me automatically. It will be showing that this VPC will be creating this, but it will not ask for these particular, because it will be saying, it will be suggesting you that this particular CIDR is free for VPC. Is it okay for you to take this? Then it will be saying this particular CIDR is available for subnet. Is it okay for you? So by default, it will be giving you some of the suggestions. You normally do what is you spin up EC2. You take the suggestions itself. You click apply. It will apply all these basic underlying. If you'll afterwards spinning the EC2 now and go to the console itself and see what are being spun up instead of EC2, it will be showing in VPC. You have that VPC with that CIDR right now in place. You have that subnet with that CIDR right now in that subnet. That EC2 instance is working. Okay, understood. Now the thing is, what I was talking of is VPC. This is what the range. Range means amongst all these addresses, I can now use any of the address. Outside this address, so if my VPC will be of that range, I'll not be able to use 10.2.1.9 because it will be outside the range of. So my EC2 of the VPC, this CIDR, will not be assigned anytime this IP address. I can't forcibly assign this IP address to my machine, or there will be no communication. Because I'll not be having that. I was not being inside the address space. Understood? Now, what I was telling that this is how VPC works. Then afterward, when I'll be inside this, I had spun up on this VPC, then it will say what subnet you want. Subnet is basically to segregate the address spaces. Then I'll be saying to create subnet, it will say what CIDR for subnet you want. Then again, I'll be giving 10.0.2.1/24. What this means is 24 means this is 8-bit, 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 8-bit. 24 means these three are network and one is host. Now we can have total of 255 IP addresses allocated in this subnet. And the range will be 10.0.2.1 to 10.0.2.255. So now this subnet can have any of the address in between this. May it be another subnet, it will be having 10.0.5.1 for the session. Means range will be 10.0.5.1 to 10.0.5.255 because this is network space 24-bit, one is 255 addresses can be allocated. So there will be some name like subnet XYZ is this. If I'll be creating subnet in AWS, it will be giving XYZ subnet is having this CIDR, means this much address space is available. A subnet ABC is having this CIDR, so this much address space is available in that basic subnet. Now, if I want to spin up an EC2 instance, let us suppose in subnet ABC, it will be asking me that if you want to spin up EC2, on which VPC, on which subnet you want to spin up. So if I want to spin up the subnet in my VPC1, subnet ABC, then I can have a liberty to use IP address within this range only. Means I can use 10.0.5.29 as IP address for my EC2 VM. But I'll not be able to use 10.0.2.29 as IP address in this subnet because that will be out of the range. So it will give some sort of error while creating the EC2. So in reality or in actuality, AWS normally give the IP address by default until unless we want the static or initial IP address to be changed by ourselves. We have liberty to say that, but for simplicity or for usage of noobs itself, AWS is automating all the things. So we can say we had used AWS without actual knowledge of the terminologies and all. So it will automate the things for us. So that each a 5-year-old child or 10-year-old child can also be able to spin up the instances over there. So we should not be in that way. We should first understand what basics are, then so that we can troubleshoot on. Okay. You people understood the basic terminologies of what subnets are, what VPCs are, and what EC2 or VMs are, which are being spun up over here. Understood the basic terminologies? Perfect. Now coming on to the actual trade, what we need to talk of here is when we will be spinning up EC2 instances. Now we will be saying something. Subnet can be public or private. If I will be serving the web server from EC2, let's take an example. We have an EC2 instance spun up and we have installed a web server package with website on that. in general sense, I want to say that let us take an example now. This is on any VM itself. I have spun up a web server with a website package on that, and I am serving that particular website to the external users on internet. So what will be the topology? This particular VM will be having some sort of IP address which should be public. Let us take an example. The IP address is public for sake of simplicity. It can be accessed from internet itself. So it will be having public IP address. So what topology is? User will have browser. In browser, he'll write URL of website. URL of website. To resolve URL of website, the browser will send a query to DNS server. DNS will in turn give the address of IP address of that particular server to the browser. Then browser communicate with that public IP. And in turn, the VM hosted on that public IP address web server will be sending web page. This is how actually transactions go on to search a website. So let us take an example. This particular VM is having 64 GB of RAM and 12 core of processor. And it is okay to serve 1 lakh concurrent requests. Now, 1 lakh people from their individual browsers can always hit onto this public IP address, and if this particular web server is competent enough or powerful enough to serve all those. Let us take an example. On a day, the website traffic goes on. Let us take an example. If there will be Big Billion Day, or if there will be some sort of holiday or some sort of festival, the website requests goes on high. Let us take an example. 10 lakh request search. Request search means normally what was under 1 lakh is now surged upon to 10 lakhs requests. No, this server will not be, this VM will not be as per their own creator. Because of the limitations of RAM as well as processing power, it will be able to serve only under 1 lakh requests. And if more requests will come, either it will deny or DDoS. Denial of service will be going from here. Means to the normal user, it will seem like the website is down. This normally happens. Website down sort of thing will happen. So what is the resolution? Resolution is to create ten servers, like 10 VMs, and they should serve parallelly. Each will be having capacity of 1 lakh transactions. So 10 will serve parallelly 10 lakh. If the requests will be split upon onto them. So now here users, which are 10 lakh. So what normally here in previous we had seen that browser DNS will give the public IP address of VM itself. So it is not the case that all the VMs can have the same public IP address which will be resolved by the DNS itself. It is not possible. because IP addresses, public IP addresses needs to be unique. No two machines over the internet can have same public IP address. So all IP addresses will be unique. May it be .1, .2, .3, .4, .5, .6, like that. And what DNS will be resolving to, if DNS will be resolving the URL to, and DNS can always resolve the URL to one IP address only. It's one A record. So if it will be resolving to .1, then all the 10 lakh requests will go to .1 IP address. If it will be resolving to .4, then all the 10 lakh requests will be going to .4 itself. No purpose. Means actually problem is not solved. The whole of the burden will be going to any one of the VM, and it will be then denying the service. What needs here is a load balancer in between. Load balancer is nothing but a VM hosting a software package. What can in very simple manner we can say translate the requests, or which can forward the request in round robin. Very simple is round robin. That is we talk of. You know what round robin is? Round robin fashion.
Yes, sir.
It will be doing what in sequential manner. Let us take the first request is coming. It is going to first. Second request will be going to second. In a rounding fashion, it will be basically scheduling all the things onto a loop itself. So in this fashion, what will be happening is 10 lakh requests will be served to 10 machines, 1 lakh each. Understood? So DNS URL, because load balancer is a virtual machine itself, it will be also having an IP address. Let us take an example. It is having IP address of .30 itself. So what we need to have DNS record updated to, the URL should be mapped to the IP address of load balancer. So all the users, if they are requesting the website, DNS will be giving them the IP address of load balancer. No, load balancer is not responsible for serving the website. It is just in a fashion making the requests round robin. So all the 10 lakh requests will come to over here in very fast manner, because load balancers are fast enough. They are like HA proxies on-premise load balancer. So they do what? They just shift the request onto any one of the servers as per the configuration. Now you know, understood the concept of basically load balancer. What concept is here?
Yes, sir.
No. Two type of load balancers. One is NLB, and the other is ALB. NLB is nothing but a network load balancer. ALB is application load balancer. NLB works on layer 3 of OSI model. To know the layers of OSI model. Maybe before yesterday, anyone had told that we know OSI. You know, na?
Yes, sir.
This works on application layer of OSI model, which is a higher layer. Now, this use case is a NLB because we are dealing with IP addresses. Layer 3 is nothing but IP network. This is use case where we are feeding up on the data to IP addresses and we are dealing with IP addresses. And this user is calling on to what? .30. 192.168.30. Anything. And then in turn, it will be translating the data to dot 1, dot 2, dot 3, dot 4, dot 5, dot 6. This is how NLB works. Network load balancer on layer 3. If it present my screen here, for NLB itself, very basic, not a difficult thing. Let us have a task defined for you to have the NLB provisioned on your VMs. Let me share. Is my laptop screen visible to you?
No, sir.
Now it is visible.
Yeah.
Yes, sir.
This is how to install and configure HA proxy on Ubuntu Linux 22.04. Share this particular. Want the link? And just open it up. This is a document, basically documentation to install HA proxy is nothing but a load balancer. It can be installed on virtual machines so that it can serve the application for servers also. Network. So there are two methods. One is very simple, what we had already used is to use the repository which is already present in apt itself. Just nothing to do, sudo apt install and say proxy. Y means you need not to say yes anytime. So if you will not be writing this dash y, then again it will be asking you want to install this or not. You need to type y onto the console or terminal itself, then it will be installing it. Believe in previous sessions you had done such sort of task, it will be not very difficult for you. Just install the package. This is another way. We are not going to do that. Actually, the configuration is what necessary. What we will be defining of what are my targets are and what is my listener. Okay. Show you here. We need to configure this particular file, which is /etc. After installation, it will be present in /etc directory /HA proxy proxy.cf. This file will come out like this. Timeout to connect client content is and should be the IP address of the VM over which load balancer is installed. So this will be listener listening to the request, and port number is very necessary. Like the requests, whatsoever kind of requests are coming to my VM, they will be associated with some port number. If HTTP requests are coming for a website itself, then they must be incorporating with by default port number 80. And if HTTPS requests are coming, they will be incorporated using port number 443. So what sort of requests I want to cater, the port number associated to that request is necessary to do over there. So what it will be doing now, this particular configuration will do the IP address of this VM and the port number of that particular port number of that VM will be opened for traffic. So this package named load balancer HA proxy will start listening to the traffic coming on to the port number of this IP. so that it can grab the request and then do the action. Action of what? To translate the request onto some targets. So here the words of what I can say, listener and target are coming into picture. In load balancers itself, we have targets, target groups basically, and listeners. So listener is nothing but in network load balancer, listener is nothing but the IP address of the load balancer itself along with the port number over which it needs to listen. And what target group is? Target group will be the IP addresses of the VMs over where actual web server or the application is being hosted, over where we need to send the requests to in a round robin or any other fashion. Target means over where request needs to be sent. So in this configuration file, previously we were typing, we were giving front end. Front end means listener, IP address along with port number. Then backend means the target group. We need to write default backend. Whatsoever the backend servers is server number something. In this format you need to write. Then IP address of that particular VM which is serving the web host may it be first, second, third. So this there can be multiple lines of server number one, server number two with IP address of second server, along with the port number over where that server is listening to the request. So if that is web server, by default, that will be listening onto the port number 80. So this load balancer will send the request to port number 80 itself. Now, in this case, maybe that server, which is hosting website, actual server, is listening to port number 8000. So now we have configured like that. This particular load balancer is sending the request to port number 8000 of the web server having IP address. So in this fashion, we can have multiple number of targets. And the total number of targets inside my backend server is called target group, having 10 servers or 5 servers or anywhere where we want to do the thing in a round robin or any way fortune. So this is the basic configuration of HA proxy. There is some sort of advanced configuration also. We are not doing for that itself. In future sessions, maybe we will be talking about. So that is how to change the scheduler algorithm. May it be round robin to another or whatsoever. Okay. So today we will be discussing of what are the basics. And we then after configuring the system, we need to restart the package of HA proxy so that all the configurations will be saved and it will start serving as per the configured parameters. And it is showing that after curling or doing any sort of request onto the load balancer, it will be redirecting to the actual web server and the website web pages coming on to the client itself. Okay. Now, you understood actually what this whole package, this documentation is all about. Now, let me again give you a brief that what actual task you need to complete. Here. Now, each of you people need to do task of installation of HA proxy or network load balancer onto the virtual machine you already have in your system laptop. You have virtual machines already spun up, Linux virtual machines?
Yes, sir.
Yes. Following the particular document, you can always install the HA proxy web package and you can always configure it out. Yes or no? I believe configuration is not a heavy task. You following the document, you can configure it out. Now, what I need is there will be some sort of VM with HA proxy. Will be having some IP address, and you need to configure file. What I told you in configuration, what you because HA proxy is a load balancer, it will be having an IP along with port number. So that combination is called listener. Listener will be active, and file will be having multiple IP addresses. IP address 1, 2, 3 of various targets. Target is nothing but web server VM. VM. Web server VM. Okay. And all the IP addresses combined is called target group. Okay. I believe most of the infrastructure you already have. One, in previous task itself, you have created web servers. Few of you have created web servers. Those who have created web servers will have their web servers spun up on their VMs itself. Problem. Those who had the FTP servers will basically all will be having HA proxy in package installed on their VM for testing. But the persons with FTP server previously installed, they will be when they will be installing HA proxy on their VM. Actually, their HA proxy configuration file must be configured to forward the request to the actual IP address of web servers, the persons who had installed web servers in the previous task, so that those actual web servers can be consumed for transferring the traffic. Understood? Understood what to do? Today, this task will be given to Priyanshu is available over here. Priyanshu Badaya. Is Priyanshu here? Anyone there at Bangalore can acknowledge his presence?
No, sir. He is absent or didn't come to.
So if he's absent, then how he has joined the session itself? He's not in office.
He is doing work from home.
Okay. Anish Bhardwaj.
Yes, sir.
You available over there?
Sir, I'm in
Can you
Bangalore.
please switch on your camera? Yes, Anish.
Yes, sir.
You understood what terminology is?
Yes, sir.
So you had done the previous task, and what team you were?
NFS team, sir.
NFS.
We have for the NFS server. Excellent.
So you will be the leader of this task itself.
Okay, sir.
And the actual task you need to understand very briefly is to configure a load balancer and to test its capabilities and working capabilities. Okay. For that reason, what I am suggesting is because already you people have done some of the job like installation of web servers. Because one team had already installed the web server. So for their testing purpose, they can always install HA proxy onto the server. But for the point in time, whosoever had installed the web server in the VM, and if that web server is currently serving, don't install the HA proxy or load balancer on the same web server till the task is over. Afterwards, he can always exercise the things or practice onto. But right now, because web server is hosting on is consuming port number 80 itself, and if I'll be installing HA proxy again on that also, and we want HA proxy to consume also port number 80, then there will be conflict because port number 80 is a single port on a VM and it can't be shared between two different services. Understood? So the people who have installed web server just need to fine tune their web server, have some sort of web pages onto them. Okay. And the people with the FTP server previously installed, the team who had installed FTP server, they need to install HA proxy. And okay, basically, if they all will be installing the HA proxy, their VMs, whosoever on where they will be installing VM, HA proxy, will have separate IP addresses. So to test all those separate IP addresses, we can always ping on to their IP address for load balancing purposes. So they all will be, let me take it. All others, may it be FTP team or may it be NFS team, or the third one was DNS team also. All others need to install HA proxy on their servers, on their Linux machines, and then need to configure the file whatsoever is given so that all the targets should be the web servers of the team. Web server of the team what had previously installed web server with the IP addresses as well as their port number. Finally, day after tomorrow or so, we will be testing by pushing the requests onto each and individual HA proxy load balancer IP address, and we'll be seeing that whether the things are going on in a good fashion or not. Actually, we are getting the web page or not. That will be the result. Understood?
Yes, sir.
All. So basically, your name is Anish, na? Anish. Anish. So Anish is team lead, and all other people need to communicate with Anish itself so that things can be done in a proper fashion. Okay, because previously the DNS was set up by Gautam itself, so he'll again be installing HA proxy. Just have an interaction with the all other team members, do the thing in right fashion, have the output. Okay, so this is your task for today. No, we'll be talking of ELB in next session because it is late today and we had covered the other things also. So Monday we'll be talking of ALB and how load balances on cloud works. Brief session, that is not bigger topic now. So what other blueprint deployments, all other things we'll be talking on Monday. Along with that, what else we'll be covering on Monday is the containers on Linux. How containers can be spun upon Linux, and what is basically containerization. What is the need of containerization? VM versus container. Difference between VM and container. How containers can be made also container images, that is Docker. Docker will come into picture Monday. ALB. We will be clearing on to these. And what else we will be covering on Monday? I'll write it on chat box. I'll define you what we will be covering on Monday itself. So because the topics are very lengthy enough, so everything is filling up onto the next days itself. Like today's topics are being filling up onto the Monday topic. So now that is what we will be covering. Afterwards, what I expect from you today is the document files of yesterday task in chat box. Understood all? Document file of yesterday's task in chat box. What other thing I expect from you is today's topics covered in chat box. What we had covered in today's session. I believe yesterday also few people had written that what we had. All people are not engaged in the activity itself. So just feel free to engage in the activity. I want all your people's input, not just 4 or 5 people's input is not enough. We are a team of, I believe, 20 people, and there must be 20 outputs in the chat box. I'm expecting 20 outputs. Understood? So I want all people to write what you have got today, what you have got in your brains, what you have absorbed from today's session. So that will do a purpose of revision of the today's session in your mind. When sir, you will be thinking of now what we had completed, that will revise the topics in your mind. That has a purpose. That is why I told you yesterday and 2 days ago. So I need an output from you people. Today, without fail, I need as much information, as much information as you have got in your minds written on chat box. Like if you have got Hadoop, what basic lines of Hadoop you can always write. Just start writing a sort of paragraph or so. That will again uh, make you people aware how to communicate, how to write the things up. Okay. I want this thing from you people also. And today's task is not very difficult. That is also fine. Because today is Friday, tomorrow, Saturday, Sunday. That is also fine. Document files, today's topics. Task. Actually, see, as team effort. This must be a team effort. And you know what Monday we will be covering off. I'll be giving you brief also that what on Monday extra we will be covering. Okay. Anyone, any question till now for today's session or any previous session? Should we wind up today? Done? Done. Thank you all. Thank you very much.
Thank you, sir.
Okay, sir.
Thank you, sir.